Hello, welcome to a lesson on molecular formulas. Now, molecular formulas are true formulas. They're the actual number of atoms that are present in that compound. It can be determined from the empirical formula and the molecular mass. So you would need both of these. The molecular mass will always be given to you if you're trying to find the molecular formula. You may, however, have to find the empirical formula first. So we'll do two examples, one where they give us the empirical formula and then one where we have to find the empirical formula first. So in order to determine the molecular formula, first thing you have to do is calculate the mass of the empirical formula. So your empirical formula mass needs to be found first. You're going to use the periodic table, add up the mass of each element that's present in the empirical formula. That gives you the empirical formula mass. You're going to take the known molar mass that they've given you in the problem, divided by the empirical formula mass that you just found. This is going to give you a whole number, and that's going to be the number of formula units that are in the compound. So you're going to take that number, multiply it by the empirical formula subscripts that you have, and that's going to give you your molecular formula. So the number that you found in this step is going to give you what you're going to multiply your empirical formula subscripts by to give you your molecular formula. So let's look at an example. We're going to calculate the molecular formula of the compound, sorry that got stretched out like that, with a molecular mass of 60 grams and the empirical formula CH4N. So the first thing we have to do is calculate the mass of our empirical formula, and it tells us that our empirical formula is CH4N. So carbon is 12 plus 4 hydrogen is 4 plus 1 nitrogen is 14. So that gives us an empirical formula mass of 30 grams. You're going to take the molecular mass that they gave you up here, which is 60, molecular mass, 60 grams, divided by the empirical formula mass, which is 30 grams, and that's going to give you a whole number, which is 2. You're going to take this number, and you're going to multiply it by the subscripts that are present in the empirical formula. So 2 times 1 carbon is 2 carbon. 2 times 4 hydrogen is now 8 hydrogen. And 2 times 1 nitrogen is 2 nitrogen. So this is our molecular formula. So we have taken that whole number and used it to multiply the subscripts so that we can get our our molecular formula from our empirical formula. Now, this has given us the percent composition. It has also given us the molecular mass, and they are asking for the molecular formula. So the first thing we have to do is find our empirical formula. So remember, percents can be assumed that they are grams. So this is going to mean that we have 2.8 grams of hydrogen and 97.2 grams of chlorine. Remember, we need to turn our grams into moles. So 1 mole over the mass of hydrogen is 1. Chlorine is going to be 1 mole over the mass of chlorine, which is 35. So our hydrogen, we have 2.8 moles of hydrogen, and chlorine, 97.2 divided by 35, gives us 2.777 mole of chlorine. Now you divide each of those by the lowest number that is there. So in this case, the 2.777. So divided by 2.777. That gives us 2.8 divided by 2.777. Should be extremely close to 1, which it is. You get 1.00. So we're just going to say that we have 1 hydrogen and then 2.777 component divided by itself, obviously, is 1 chlorine. So that means that our empirical formula is HCl. Okay, so now we need to find the molecular formula here, or molecular. So they gave us molecular mass. We have to find the mass of our empirical formula. So our empirical formula mass, hydrogen weighs 1, chlorine weighs 35. It's going to be 36. You're going to take your molecular mass divided by your empirical formula mass. They tell us our molecular mass up here is 36. And we just found our empirical formula mass to be 36 as well. That means our multiplier is 1. So 1 times each of these subscripts means that our molecular formula is also going to be